Bit 4 selects a triangle waveform output of oscillator 1. Oh, hi everyone. I'm going to welcome you to my YouTube channel. This is Steve coming back with another video for your enjoyment. It's been kind of a while before I've actually got a video out here. It's only because I've actually been working on a really cool program I'd like to show you guys. It's got part machine language and part basic in it, so it's not full, machine language or full assembly language, but I think you guys will enjoy it. So let's get that started. Oh, and one other thing, guys, I wanted to mention, really importantly, that, somebody at work kind of pointed out to me. I was trying to teach him something about, basically simple programming and stuff like that, and he's like, you're talking over my head. So I really want to know, if I'm talking over your head at any time, if there's something I can break down, if we have to break it down at Sesame Street level, let me know. I don't really want to go ahead of anybody. The whole idea of this channel is to really teach you what I know and, what we can share together. So anyways, let's get started with this. Okay, so the program I'm going to be showing to you, it's called Awesome Jukebox. And I just noticed I spelled jukebox wrong. It's more like a jukebox or something. But the whole point of this, you'll see it, it's actually a musical jukebox. It plays, well, it plays some simple tunes right now. And it's actually playing everything directly out of this book. I got the idea when I finished this book, the C64 User's Manual. And I thought, it would be kind of cool if I could put together some kind of a program that could play music, because myself, being a musician, I would love to be able to see a program on a Commodore 64 that could actually play it by musical notes. And, well, it's not perfect, but I've done that. I've actually allowed it to look at the notes and play them individually. And also, it also operates as a keyboard, so you can play it like musical notes. You'll see that here in just a second. So let me just run it. This is the code right here, and it's also got some machine language routines implemented into it to kind of speed up the process. So, okay, so this first thing I just added this recently today. I had finished the jukebox just yesterday. Actually, it took me a matter of 2 days to get it working, and this is actually just going to basically pick the waveform of the kind of sound you want to produce. We got the triangle waveform. As I move my little controller here, I get to kind of go through the list here. So sawtooth waveform, pulse waveform. There's a test bit. I couldn't get that one to work right. There's a ring modulation, and I think I covered them all, right? Oh, and there's a random noise. I think that was everything. Ring modulation. So I'm just going to pick one here. For example, sawtooth, we could listen to that one. The normal one is triangle. So we'll do triangle first. You just hit the enter key here. Oh, got to hit enter. There it goes. And then it gives you a simple little menu here. Do you want to listen to the jukebox, or do you want to play the keyboard? So we could do either right now. So I think first what I'm going to do is I'm going to choose the jukebox, since this is what it's all about anyway. And it'll play the notes. That's already built into its memory. And this is that Tom Dooley song directly from the book. It's only playing the short tune of it. I could additionally add it later and make it update. And you notice as it's playing also that it's showing the exact keys that it's hitting on the keyboard to play that note. And you'll see why later, because these keys are assigned to those individual keys. Or you see like the A sharp, B sharp, C sharp. And when I'm looking at it, this is like an A sharp, a B. Let me just stop this for a second. This is a B and this is a C. And this is a C sharp, a D sharp, E, an F, and an F sharp. So from a musical standpoint, it's playing them exactly as they're tuned and how they're supposed to sound. But it also can play not only just in sawtooth, it can play in different variations, and let me show you that too. So you saw me at the menu here earlier when I selected triangle. This time I'll select sawtooth and show you. I have to activate the keyboard there. Okay, so out of jukebox again. And now it's going to play sawtooth. Hear how the sound sounds a little different. It's also at the same time showing you the notes that are being played. These are the high and the low, which we'll probably go over that later. This is the duration for each note that's held. And if you need to know, like from a musical standpoint, there's quarter notes, there's half notes, and there's 1/8 notes. And basically it's playing in those accordance. So according to the book here, the quarter note, actually, let me pull it up here. Yeah, here it is. The 8th note is 250. So you saw the 250 here. The quarter note is 500. the half note is 1,000 and the whole note is 2,000. So that's how long it's going to hold that pitch until it lets go and plays the next note. So next thing we'll do here is we'll run it again, and I want to show you the other ones that's built in. We won't go over all of them because the ring modulation, I can't get those working to test fit. These are all according to memory location 54296, I think it is, or 276. So it's the voice 1 control register. As always, I'll show you the book right there. See it, 54276 there. So we'll go ahead and select a different one. Pulse works, but it's kind of a real low sound. You can't really hear it. So random noise. This one's interesting, especially when we get in the keyboard later. And we'll run a jukebox here. It's got like a more of a gunshot kind of sound to it. So it plays in an order. And now we're going to go ahead and we'll have some fun here. We're going to look at the other part I implemented into this, which is the musical keyboard. Took a while to get this all working, but eventually, and it also allows me to select the same thing, just like usual. I could select random noise, I could select pulse. We'll do and start with triangle again, and this time we'll choose number 2, a musical keyboard. So it just moves to a different part of the routine now. Now as I press the keys, allows me to play them as you would hear them sounding. Like if you listen to this one, that's an A sharp. If you listen to this one, it's a D. Here's another D, a C sharp, a B, and these are different octaves. If you want to know music, it's different variation of the sound in pitch and that. Q for some reason doesn't light up. I have to work on that one, but they're mostly all working. I mean, they're all working pretty much, so. And if I wanted to play it, you could almost play a song with it. I'm going to refine it a little bit better later so that basically it makes more from a musical standpoint. Right now it's kind of like you just hold down the keys and it kind of just plays them. So what I was thinking about doing is maybe having a list of like keys, like a list of what do you call it, notes, and then you could basically type in the notes like on an input line or something, and it'll enter them into the keyboard and run them. But that would be a more of an advanced process for this project. So we're going to go ahead and look at the other different variations. Sawtooth is going to sound just like it did earlier. And I'm just using the joystick again. Change the controls. Sawtooth. And this is that little higher sound to it. It's a Commodore 64 sound you would usually hear in the game and stuff like that. A lot of music's used to sawtooth. You notice these don't have any duration because I don't have the keyboard set that way. You can kind of hear these ones now. These are a little bit longer. I was trying to play a song, but I can't get it. There's a little bit slight of a delay, like when it releases it, so plus I don't really have them all memorized, even though they're in order. I got something like this, maybe. It almost sounds like a song. Anyways, that's all the musical part of the keyboard. Now this one's really interesting. And we'll look at the code here and all that in just a minute. The one you saw playing earlier, the random noise. This one's really cool. Gives you all the different kind of sound effects to it. Different kind of sound effects to it. The ones at the top are interesting. There's like a gun sound. Getting deeper. Okay, and play with it all day here. Now I'm going to show you the code. And now to explain this in a lump sum as easy as I can here for those who want to know. This right here is just setting the border to the colors since the game itself resets them to the black border, and I just wanted a different color for like the entry screen where you enter in from the controller to having the choosing the jukebox or the musical player. And everything here, these are just setting up, this is setting up the sound initialization for the SID chip. 54272 is a memory location. And this is setting up the duration whenever the automatic jukebox is playing. This we'll go over later. This is just basically using for some variables I use to control information that's being entered into memory to check where these keys are being individually stored to compare them against another register that kind of compares where the notes are and plays them in order. Okay, so we got some go subs going on here. So let's look at the first go sub here, 410. You always follow the go subs. That's how you kind of read a program. You go to that line, and it'll return back to that line later. So here's where I actually read into notes. So KY, actually first is what this is doing is it's reading into keys, because we want to know which key are we pressing or which key are we going to play. The next one here, this is the note. The N1 is actually the low note, and then we got the high note. Now I don't know if I really explained that in this book here. When we went over this guide, I'll show you in the back here actually. This is where I got all this at here. Right here. I think I did show you this before. This is where I'm getting all this information. You see these notes right there? These are the actual notes that you saw playing on the screen earlier. When you were looking up here at the top of the screen, they were playing there. And then there's some more here on the back. These are the rest of them. These are like the octaves and everything. There's many more notes you can play than this, but I didn't really have a whole lot of room to put them all on there. I just wanted to play just kind of a few for now. And if you wanted to play more later, I'd have to activate like the control key and stuff like that to be able to put more musical notes in there. But it's just an experiment for myself to see if I could get it to work, and apparently I was fortunate to get it working. So as we play the notes, this right here is the SC, so this is a screen location I stored, and these are being stored in data statements if you remember the read. The screen is basically going to tell it where to plot that character once we found the key location and we know which key we're pressing and where to plot it and stuff like that. So I kept track of the screen memory locations every time you read a key. You see the notes that are in that order. Then you also know exactly once you press that key, you can look at that same list and you can get the screen memory location to plot it. And the last one is the letter to show you the letter that's going to appear in that screen memory location. Now here's where it gets a little bit interesting. You see, well, this is reading in the keyboard right here. K equals 1, -1, then return. And you see this poke 49310 plus VB, comma KY. What this is doing is basically storing all of the keys into memory so that we can compare them against another location that's going to hold the notes separately. And that's in this program behind here in CBM PRG Studio. To try to explain this process to you, it's going to be a little bit more involved, but I didn't want to kind of jump out of program and jump back in here. So we'll come back to that here in just a minute. But just remember, it's storing the keys, and then we're incrementing them, get all the keys stored in there. We're using a couple of arrays here to keep track of the keys so I know how to plot them back on the screen once I press a certain key. And originally what I did is I set it going through a for loop, but I found out the for loop was really slowing it down, and when I press a key, there would be a horrible delay before I could press the next key and so on, or it would play the next key. So I finally decided, no, I'm going to really put it together. I'm going to create an assembly language routine that works directly with it. And anyways, let's move on from there. So after we get all the keys in here, we just keep reading back, and then we're going to return once we got all the keys located, the notes and everything that's saved in the arrays. Next, we got here go sub 1602, and I think this was the original keyboard routine I added, or the joystick routine I added earlier for the controller. It just shows these are This right here is setting up, if you remember, the home, the down. This is setting up the cursor position so we know where to kind of put the messages when you first saw me moving the controller, selecting sawtooth and random noise and all that stuff right there. And these are just storing these in arrays right here so I can print them out as I'm scrolling through it. It allows you to scroll. The reason why that's good is instead of having to print them all on the screen, you could just go and cycle through this string array, and it could pick up the next one, the next one, the next one, and so on. It's kind of a cool thing to do for the Commodore 64 or any kind of computer. This next one here, these are actually storing, and I notice I've got these, but I probably, let me see. Yeah, I am using these, I believe, so. Actually, you know what? This was going to be something else I was going to do to it later. I was going to have it set up individual voices and stuff like that, and I need to probably get that still implemented. This is going to set up more the sound that you were hearing from some of the sounds that didn't work. So I kind of went a little bit ahead of myself, but I still need to finish that. I'm just setting those up in multi-dimension arrays. So these are keeping track of the values that's needed to play very specific sounds like the test bit you saw earlier and the synchronization, oscillation, and just things like that. And it's all according to that book again. So if you look at that book, like I said, it's all directly inside of there. This is where I'm getting it, and this is where I got the ideal from. Get back to the page right here. So what I'm referring to with these locations you see on the screen right here, and you see it says WV1, 2 equals 255, and you see this 1, 4 equals 65, 9, and so on, and down here you see different values. This is basically looking at these values right here from that book. We'll take a second there. You see it says piano, it says 225, 65, 64. This is basically taking the harpsichord, the xylophone, the accordion, the trumpet, flute, and so on, and I'm going to insert them into these multi-dimension arrays later, and I can play them back so that they sound correct. As of right now, I just got the general waveforms working, but it's something I could move on to later. All right, and let's go down here. So here's where you saw the message earlier, what waveform. Just prints a simple message on the screen. And then from here, it's picking up the joystick location and allowing you to read the joystick or the controller. I would say joystick because I grew up with joysticks. Hints. Okay, and then also here, we're reading in the keyboard. This is how you read the keyboard on the Commodore 64. It's one of the ways you can read it. Is by peeking in memory location 203, which is one of those registers stored in your computer, out of 65,535 different registers. And this is saying if KB equals 1, then we're going to skip all this stuff right here and go down to 1810. That's just saying if you press the enter key like you saw me earlier, then we're done cycling through the list. We selected what we wanted, whether it was a waveform, sawtooth, triangle, and then now we can go ahead and start running the actual program. And then from here, we're just positioning the messages. You saw that WV I mentioned earlier. This is just cycling, allow you to cycle in through them with it. You see the WV variable inside of here. It's just right here is a word actually does a cycling. So this is reading the joystick, passing a value down to this location right here. So now there's a value passed in here. It's able to read this on, remember this on routine is basically picking up this one or this one. It's picking one or the other based on whatever this value right here is. As you can learn that from my very basic tutorials, I do have another video in there where I talked about that on the beginner series. But it's basically just saying, are we going to this one or are we going to this one? So are we moving the joystick, are we moving the controller up or are we moving it down? And if we're moving it up, I think this one is up, it's going to go right here and it's going to read in this routine right here. Yeah, this is it. WV equals WV minus 1. So that allows me to move it in both directions to cycle through the different selections. And this is just saying go through all 6 selections. If you get to, or if you get less than 1, then cycle it back to 6. So it flips right through all those different ones. So I can just kind of keep cycling through them. This one right here is kind of a trick I learned quite a while ago when I originally did the Quest for the Mad Bomber program way back when and sold it to Lodestar. This is actually a logic routine, I think it's called, Boolean logic, where basically it was going to say, first of all, what you want to do is you want to look at this value right here, WB equals 6. So what this is doing is it's looking at, and I think I have my list here somewhere. Yep, it's right here. Well, I could kind of look it up here real quick. So it's looking at number 6, which is the pulse, and it's saying, have you selected the pulse in that list? And if you have, pass in waveform value 2 so we can play it for whatever that value is stored in 2. So it's basically passing in bit 2 to play this one. And this is doing the same thing, wave 5. So it's saying If you've actually selected, for example, the sawtooth, then we're going to pass in bit 8 and so on and so on. And that's just basically how it's playing the values so that you're hearing the different kind of sounds that's being produced through the Commodore 64 there. And I was going to look these up in the book here real quick to kind of give you another peer insight of what I'm talking about here. 54276 right here. So right here you can see it shows, sorry about that, 54276 control register, and it shows gate right there, and you see ring modulation, triangle bit. So it's basically setting these bits. You see these bits here, 2, 3, 4, 5, 6, 7. That's what these are doing right here. You see 2, 8, 16, 32. This is how it's converting them. Now, if you need to know a little bit more about that, you'll basically want to take a look at this. I've shown this many times. This is my Excel document, which has all the memory locations for the Commodore 64. It is totally complete, so get it on GitHub. I'll try to throw up a link there again. And these are the bits right here it's passing in. So you saw those being defined in that variable 64, 128, and so on. It's just basically taking those bits to pass in to these values to figure out what waveform or whatever to play in that case. And this is checking the joystick down for the down direction right here. So if JB is passing in this value here, and it's checking it with 15 there, then it's going to say go to 1780. And at 1780, we're just going to increment forward through the list so we can kind of see the list in the forward direction. Just kind of give it more variety. And then we're going to do the same thing. We're going to pick that value out for the waveform. Once we have it, right here, we're going to wait for the keyboard to be pressed. Remember that KB equals peak 203. So once it's equal to 1, it's going to now go to 1810. So we'll get down to there. I set this to reset this. I probably don't need this because originally I was having some problems with it. This just kind of resets the keyboard. And this is going to position in some more messages. You saw those earlier. Now I put these in some simple arrays, but if you need to see them here, I'll show you what they're basically printing here. Right here, if you see where it says KB strings equals auto jukebox, or 1, KB strings 2 equals musical keyboard. So it's picking either the auto jukebox or the musical keyboard, and it's just printing those displays for us. And that's the position I'm on the screen as usual. And it's just getting an input value to say, is the value less than 0? Because we don't want to enter a negative value. If the value is greater than 2, then we're going to keep going back to this loop and don't allow you to enter any other values that don't make sense. Once you have the correct values, however, what it's going to do is it's going to use that Boolean logic again, and it's going to pass the value this time into JB. So you can use this for any values you want, and I'll show you another one I did down here to transfer it into this one. So what this is saying is right here is that the value entered right here, is it a 1? See, it says in equals 1, input equals 1. If it is, we're going to set JB equal to a 1. So notice that equal. That's how you identify what it's going to be set to. And over here is the value we're entered into the keyboard for 2, which is the musical keyboard. If it is, passing to 0. And this is used later to turn on either the keyboard routine for the semi-language routine or turn on the routine for the jukebox. And down here below, you see something very similar to what this does. It's going to basically look at this information after you entered in here, and now we have a value for JB. So now it's going to look and say, is JB equal to 1, since we set it to one of these directions, either 1 or 2, based on whatever we typed into the keyboard there. And if it is, then we're going to pass it in. We're going to create this ML variable. We're going to set it to 49152 if you entered a 1 at the keyboard. So basically, if you entered the jukebox, then we know we're going to use a system call for 49152, and then it's going to do vice versa for the same thing. If you don't enter any value there, if you enter, the second value, which is a musical keyboard, it's going to set JB equal to 0, and it's going to pick a different routine. So say if it's not this one, then it's this one. So it's going to syscall either to 49152 or 49206, and this is the way I did it, without having to make it switch inside the loop and slow down the program, essentially. Which I'll show you that here in just a minute. So this next one is, I had to throw this in. It's kind of a bug I need to work on, but for some reason, sometimes this WF value that here Boolean's being set earlier seems to throw it to a negative value. So I said, if it's setting it to a negative value, we're going to default it to a 17. I think that's a sawtooth or whatever, and just let it play that way. And then this one is just saying if the input value is greater than 0, that means we entered an entry, then we can now return. So that means we either entered the musical or the jukebox or the musical keyboard. And then now we're back out of that loop. We're going to go back to the Go sub. All right, so the next thing we're going to do here is go to 2010. And I think this is just a simple routine for drawing the screen. Oh, no, this is actually more data. I forgot. Okay. Now we're going to be reading in some more data, and this is the data you didn't see earlier. These were the keyboard values, if you remember, the note 1, the note 2, the screen memory location, and the letter. That's basically what I do is I have a giant list here, and I'm just going through this list, and I'm reading it through as I know which keyboard to press or which key to play and where to plot it and all that kind of stuff. This one is going down to a further list, so I'll kind of separate this one to show you the list. So let's see, 2010 through 2070. So I can kind of isolate them there to show you, make it a little bit easier. Oh, some of them went off the screen here, but anyways, this is the list that we actually need that will work. So this list, what it's saying is it's going to read an NT string, so it get basically one of these values right here. It's going to look at and say we've got a D chord, or I'm sorry, D note, note D, and we're going to basically read that into NT strings. I don't think I've done anything with this. I had some other plan later where it's going to implement make it just look at a series of notes and play them that way. And for now, I just have it reading it directly, and you'll see here the memory location. So we'll get the NT strings, and that's reading the first value. And then next, we set a value to read into the data statements, just reading one after the other. Read NTs, read KS, read DU. So it's going to read the keyboard. I just called this the keyboard saver, keyboard scan, whatever the KS stands for there. And it's going to pick up values there for the keyboard now. And it's going to, you notice the 37, 37, 45, 12, 28. That probably doesn't make sense to you yet. But if you remember that value we went through earlier, which was the KB equals 204, that's reading into keyboard. So I'm going to show you this little list I have created here. These are the keyboard routines that correspond to the keys you saw me playing earlier. The Q, W, E, R, T, Y, those are the keys at the top of your keyboard. These are ones in the center. And these ones on the inner are on the bottom. So this basically what this is doing is it's looking at those values and it's storing them into the program so it knows which key you pressed and which one to play. Vice versa, whether it's a musical keyboard or it's a musical jukebox, both. And then this is just setting the duration earlier. This one is currently only going to work for the jukebox, since we don't really need to really have a duration on the keys because we're not going to sit there and try to play this key or that key. That might be something I might need to look at a little bit later, but for now I just want to make it real simple. So we got the duration, we're reading in that into DU, and down here this is just checking to see if this is a negative value. Right here we got a negative value. Then we're done with the data list and we can exit back out. 2070 is going to return because of that Go sub. But before we do that, I set this one here just as a stopping point because I had some errors saying if there's an X here, then we're going to return or pass some. I threw this in to test it, basically to change the border color and return back, just to kind of, catch any errors that were going on. This right here is storing the end strings into, into a string array. It's going to take the value of CT and it's going to keep incrementing through it to keep storing these into different increment of string arrays. So it can keep track of the list that we have here. Each one's going to keep track of each of these lists in the string array. Well, that's for the first one. That's for the D and so on. The next one here is keeping track of the keyboard entries for KSCT equals KS. So it's keeping track of all the different keyboards. I'm saying keyboard. Well, these are the keyboard, but these are the individual keys that's going to be assigned to these individual letters. So it only needs to play these notes only and not sit there and try to play every single note on the keyboard. And believe you me, I had a lot of problems where it was, sometimes it just wasn't playing, or sometimes it was playing random keys. I'm like, I have no idea what's going on. So it took me a little bit of time. I had to play with my loops a little bit, which we'll go over that machine language stuff when we get to it here. And you'll see that'll start hopefully making more sense to you. I know this is a pretty complicated process, but anytime you're building something complicated, it's going to be complicated at first when you first try to comprehend it. I know to myself, it was just kind of rattled me a little bit. Okay, so once we've got the keyboard stored, we're next going to look at the duration, and we're going to start storing into duration. So kind of the same thing that we were doing earlier. Now here's the kicker. This location right here, poke 828 plus VL, it's going to store all of these values that we're entering in for the KSCT. And remember, that's this one in the center, and it's going to store it in the array right here. It's going to store it here, so it keeps track of all these keys. So what I'm doing essentially is I'm looking in memory, at a section in memory. Let's just say we have like a box set aside in memory for 828, 829, 830, 831, and each of those boxes actually contain keystrokes in. So it's going to keep track of the actual keystrokes that you're wanting to play on the screen. And it's going to sound kind of weird right now, but what it's just doing is comparing, you'll see it later, is comparing two different memory locations to check all of the keys that could possibly exist in the list out of how many notes you're going to have. So this reason why I did that is I can sit there and put in a gigantic list of notes. Once I get that working, I'll try to add that to the basic program. But for now, it's all inside of the machine language program, which is behind the scenes here, and I'll show that here in just a minute. It'll basically be able to play a bunch of notes now. I can make it play pretty much an infinite amount of notes. Okay, so what we got going on here is just read them in. Right now, it only needs to store these because we're only playing the simple notes for the Tom Dooley song from the C64 User's Manual book. And then, of course, we're going to return back out once we've read in this data and we capture that information for our program. All that just to go through the first part there. Now we're finally getting into some of the good stuff here. So 1100, I think this is the screen setup. Yeah, this is just real simple. This is just drawing in all the keys you saw on the screen earlier with the C sharp, D sharp, and all that. And it just returns off. And this is, it's always a good idea when you're writing in BASIC to use a lot of go subroutines, so you're not basically repeating a lot of code. It saves a lot of repeating because it's just going to execute simple little routines that might be able to be used over and over again. In this case, even though we're not using them, I've gotten a habit of doing this over the years, so it's a good habit to get into. So finally, we're done with all of the go subs. Now we're going to start reading in, well, this right here is clearing memory for the SID chip. You always want to clear out the SID chip so that there's no remaining sounds, or funky kind of sounds left in the memory slots there, the boxes I was referring to. And then here we're setting up the volume. I kind of documented that. This is setting up, I forget what the 3 is actually. I think it's the, it's actually, you can always go back here, by the way, to this list here. And oh, I didn't show this to you also, but kind of an addendum here. I've actually added some links into this now. So if you want to check out the latest version, you can go in here and you can click on these little links here and it'll instantly take you to those sections. I went to page 6 here, for example, and then down here I set some more examples here, so I can kind of keep scrolling through the program, not to get sidetracked here, but I wanted to show you why I'm doing this. And then here you got the sprites, vertical scroll. We'll go to the SID register since that's what we're working on in this program, and we're looking for SO+3. So down here you see some more locations here for sound. This is going to go deeper into the spreadsheet. Now we got voice 1, control, envelope, attack, sustain, volume, random. So you can click on them here, and also click this and it'll keep taking you back there. So it can find those voices, and here it is. SO+3 is the pulse waveform, and that's what this was doing right here. You saw this SO+3, and the SO+9, which is just right down here, is the voice 1 envelope. This is the attack, decay, sustain, to hold the notes and stuff like that. And then I think this one might be the release. Let me see. Yeah, they're kind of right back to back here, so that's, you always want to set those up so that you can actually hear the sound. Otherwise, you won't really be able to hear it because it's going to kind of pitch out really quick. Okay, so finally we're getting into the main loop after all of that. So we got line 30 here, KB equals peak 203. Remember I talked about that. The 203 is just reading in the keyboard to tell you which keys are you pressing. And earlier we used it just to use the routine for the enter key, so we could exit out of the front. Excuse me, we could exit out of the little list that we created for our jukebox or our musical keyboard. And then here's where you saw earlier, where we saw when we captured that ML value. Let me go back to it real quick just to kind of show you what I'm talking about here. It's right down here. Remember the ML variable? It's going to say now, remember, based on that input, are we going to put a system call to 49152 or are we going to put it to 49206? So I did this based on so that we know which system routine to call, since I've separated these in the program and isolate them for a lot of reasons. It's good to kind of separate your code like that too, just out of a habit. So we're basically going to pick that routine, and then we're going to if it's this routine, this is the keyboard that we're typing on earlier, like to play the keyboard. If we're playing the keyboard, then we're going to be able to use this routine right here. We're going to do a go sub here. If we're not using the keyboard, however, we're playing the musical jukebox, then it doesn't need to read the key B because it's not going to be looking at the keyboard. Instead, it's remember that JB variable. That JB variable is keeping track of which option we chose. In this case, JB for jukebox. We chose the jukebox, and it's greater than 0. That means the variable is set to a higher value of 0 is a good way to say that we found the value in memory for that location. So that memory exists, so we chose the jukebox, then good, and we're going to execute this routine. Now you see this peak 251, I don't want to go in over your head yet, but this is all part of this machine language routine down here that's occurring in the background. It's keeping track of saving different values for various reasons. So we're going to go sub to 810 here. Okay, so here we're just reading in two different variables, one for PG equals peak 252 to keep track of what is in memory location 252, and then P2 equals peak 253, keep track of what is in memory location 253. So these are just ways of keeping track of peeking into that value, or remember that little box that's actually occurring in memory right now. And then this right here, so you remember that 54272, this is just setting up the SID chip. And this is going to allow me to play the high and the low notes so we can get the proper values. Now, I probably didn't mention that earlier, but down here in the code here, sorry if I skipped over that, these are playing the high and the notes, low notes, which are very specific values you have to refer to in that book to get the right tone for each individual note, whether it's C sharp, G sharp, or just G or D note, whatever. Otherwise, you won't be able to hear it. It'll just be kind of a silent noise or real funny noise or whatever. Okay, so going back to 810 here, trying to stay consistent with not getting out of touch here. Okay, I went too far down there. Okay, here we go. So we've got those values, and then we've entered them into the high and the low values so we can hear them. This right here is going to pick up the memory location 252, because what I'm doing in this program here, which I'll go over here in just a minute, is I'm playing them behind scenes. I'm basically storing an information so it knows what sound to play, basically. Okay, so next down here, we've got, this is just a print message. This prints those notes you saw on the screen earlier when I was pressing the keyboard and when it was playing automatically. That's just a way of putting them up on the screen by looking at these memory locations to play them, because they're being stored in memory locations, which we saw earlier. The 828 was being stored in the 49, whatever it was, 330 or whatever I think it was. It's storing in those locations because the 49, let's look at it here real quick. I think it's 49 330 is keeping track of all of the memory locations that's being played there. Look up that value here real quick. It's 49 310, excuse me. Okay, so once we've got that, we're going to now use another go sub here to exit out of this routine just for a minute to come back to it. So what we're doing here is we're going to be actually playing those sawtooths, the waveforms that you saw me pick earlier from the list. So remember that WF value that we used earlier to pass the variable in based on whatever this value is to that value, whichever one you chose. It's now got that value stored in memory. And if you need to see it again, I'll go back over it here real quick. Kind of have a grasp on it where it is and everything. So, see WV right here, WF is keeping track of that list that you were choosing and storing it into that variable so that we can now utilize it later. Now we know whether we chose the jukebox or the musical keyboard, and essentially 1100, excuse me, is where we can finally, I'm sorry, was it 1000? 1000 is where we can finally play that waveform. And this is just picking up the different variable. This one plays the note, and then sets a little delay here, and this is keeping track of what was stored in that memory location so that we can create a proper delay. This is used whenever we're playing the musical keyboard, I'm sorry, not the musical keyboard, the jukebox, so it can play the proper, whether it's the quarter note, half note, or whatever, for the delays in the music. Because each one of them is essentially assigned to different things, and they all have their own different beats. If you know anything about music, I don't have my list here, and I don't really have it memorized, but there's different beats. Like a quarter note might play, whether it's 3 beats or whatever. A whole note plays 4, I do know that. And stuff like that, so it can properly play the correct kind of sound, so it sounds proper. And then once it gets those values played, ding ding, you've heard the values being played. Now it's going back to that routine, and it's going to finish it here. So next we're going to just change the border color. You saw the border color flashing earlier when it plays, and that's kind of add a little bit of variety to it. And then it says here PG equals 0, go to 860. I set this so that we wouldn't make a mistake with the screen memory location. The reason why this is important is because we're poking this into a variable in memory. So if we accidentally set this to a 0, it's not going to poke in screen memory. It's going to actually end up poking in memory location 0, and it could end up being fatal and could crash your program. So let me kind of explain that here. So you see this SCPG plus 1, and if I could just recall where it was in memory here, I think it's right down here. Yeah, I think this was it. Nope. I think it was 410. 410 right here. So it's picking up this SC variable, and if we go through, we're reading in that data statements here. Right here, it's picking up whether it's memory location 1507, 1510, based on whichever key it's searching for. So it always knows basically where to find it and stuff like that. So get back to my program here. I kind of memorized where all these lines are. I've been playing with this thing so long. So basically it's picking in this correct screen memory location to plot the character that we're pressing on the keyboard, or that the jukebox is picking up on. So it looks, kind of cool or whatever. And then this is just a screen memory location. The plus 54272 is allowing us to plot the color to the screen, because you've got the screen memory and you've got color memory, so that you can actually see the colors. As you're seeing these right now, these are actually being inserted directly into color memory. And then the next here, we've got, this is just a little routine I created here. I think this one is, this is clearing out those notes you saw that kind of appear whenever we're pressing the keys or the jukebox is playing them, just so that there's not, remaining numbers left on the screen for the next routine or whatever. And here's we're going to clear these 251 and 252. I did do this originally in the assembly program, but I had some problems, so I had to go ahead and clear them in here. For various reasons, we're utilizing these variables, and anytime you're using them and you're done with them, you want to kind of clear them back out. Here, we're talking about, remember that JV variable, we're saying, okay, we're going to play, we've selected a jukebox, so we're going to, now, if you remember the 828, we're now going to start picking in where that variable is being stored, and I can show you by doing a real quick peek into it here. I'm just going to set it in a simple little, so it doesn't go off the screen here. You see 37, 37, 37, 45, 12, 28, 28. It's basically looking in these memory locations saying, okay, once I played note 37, we know it's stored in memory because it's stored in this program behind the scenes for the assembly language. Now that we've tried it, we're going to go ahead and we're going to erase it so we don't play that same note again. This was a trick I had to figure out, because originally it would only play 37, it would only play 45, 12, 28. It wouldn't play the doubles. And I was like, how can I get it to play doubles? I don't know how to make the computer do that. And I finally figured out, oh, just take that list and compare it against a number that already exists in another list and erase each one. So once it's looked into like a giant number list of keystrokes that exist for the keyboard, then it can look at the next one. Since we erased the first one, it's essentially going to be able to look at the next one again, so it's just going to re-loop back again. Clear that and look at the next one to re-loop that, kind of so it can play doubles and stuff like that. So we could get the D, 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 like you were seeing the different Ds that were being played to get the right variation in music, or the sound. Okay, so that's what this is doing. It's storing them in, and what this is doing is it's erasing them. That's what the 0 does. It means it just puts a 0 in there. And I'll demonstrate it. I'll try to demonstrate with the program and stop it in the middle and show you what it's kind of doing. And once I finish this, I didn't want to go too far fast, because this is really going to be a long video. So next we're going to be incrementing through an X every time we played that note or we press the keyboard. Basically say, how many keystrokes are we going to play? Remember that list of notes? It had from 0 to 6. So we played greater or equal to 6. Then we're going to use the system call for the assembly language routine at 49,192. And what this does is it clears, it resets all these, because as it's playing each of these, it's putting zeros in them. Once we're done, we reach 6. That means that all these should be zeros because we played all of them. We're going to fill them back in with the same values you're seeing on the screen here, so we can kind of repeat it in a loop. You saw it playing over and over again. That's essentially how I got it to repeat the information. And then we're going to reset the 252 and that. And I think that covers everything for there, so I could probably go right into the assembly language routine. Yep, so we went through all this, and now finally, if you pay attention, the most important part is what's going on right here. This is where all the action is happening. This is where the semi-language stuff is going to come together, and hopefully it makes sense here. I'll do the best I can to try to explain what I have going on here. Frog my foot, excuse me. Okay, so this right here, this is hex code, so I hope you guys can read hex code. And to be friendly for those who don't, you can always use the calculator here. I'll always put this up on the screen because I'm not totally hex savvy myself. I can't read all of it. I think the reason why people get used to reading it is they get used to typing in hex a lot and start memorizing the values and stuff like that, because I'm starting to memorize a few of them. Like I know the FB, for example, is 251, and then you just know how to kind of count in this order. But this is not a hex video, but you can use this to convert them. Just go here and click on hex, make sure it's selected, and then you can just type in the value FB, and you'll see it's decimal 251. So we saw that 251 earlier, so it's going to use this inside of the program to keep track of various things, which we'll go over here in just a second. So it's going to clear them out right here. It's clearing out 251, 252, 253. We're creating a little loop here. This is just a semi-language loop to allow it to go and repeat information over and over again. Now, there's actually two different loops here back to back, so I'll need to explain those to you. The first one here is this one right here at the top. You see this increment, compare y, branch not equal. So you look at this whole section here, because what it's doing, even though it's set a value to 0 for the x register and a value to y for the y register, it's going to first look at this loop. If you see this B and E, that means branch not equal. So it's going to stay within this variable or wherever you're sending this branch back to. So think of it like a a go-to in a basic program. So it's go-to in the LP1 to stay within the parameters of this part first, because this is essential, because we're first going to be scanning through. We only want to scan one key at a time. You can't scan all of them at once because we only want to play them one at a time. So that's what this first memory location is doing here, and I'll convert this to show you, and you'll recognize it once I convert it if you don't already read it. So it converted to decimal 828. If you remember the basic program again here, let me see if I can kind of put that up on the screen here. I'll organize it a little second. Okay, so I reorganized my screens a little bit here to get so you can see everything as I'm going through the program, so this will make more sense. I like to try to be as visual as I can. So we got Vice here, and what it's doing is it's looking at, we know 828 here, and you can see 828 right here, 828 plus P2, which is keeping track of what's in memory location 252 to erase that value, which we'll see that down here. That's what these are doing, is keeping track of them. So first we're going to look in 828, comma y. That means look in this range of values that we saw earlier printed on the screen here when you saw me do this list again here, and I'll just type it in for those who want to kind of keep up with this. So I have to make this a 1-hour video. Right here you see 37, 37, 37, 45, 12. So what it's doing here is it's going to keep track of those values that we read in earlier. If you remember when I originally did that read data statements, I actually read them into that 828 plus VL, comma, KS, whatever it was. I read them into memory from those data statements so we can look at them and see which keys to play or which keys to, to type on for the musical keyboard. So it's saying, okay, let's check in that list of Y, and you see right here it says Y equals 0. For the beginner semi-language programmers, pay very careful attention here. What we're saying is once we're first going through this little routine, it's looking in memory. That's what load cumulative means. Load means look in the value in that memory location. So it's like a peek in basic. It's looking and saying, what is in memory location 828, comma Y? Give me those results. And we know because we put them in earlier into the program, which were those keystrokes. Okay, there's some keystrokes there. So I put an example here. We found 28. You can see the 28 here. That just corresponds to a different key, which I showed you earlier in this list of the keystrokes. So it's keeping track of whatever 28 is, which is showing here the B. So it's saying you press the B note, or the computer's going to be able to play the B note. So now we know there's a B note. And this first one here is actually, this is the musical keyboard, so not to confuse you. I'm sorry, no, this is the jukebox. This is the one that's playing them automatically. So the jukebox is saying, okay, look at 828, and let's keep comparing those values. This is another memory location where we stored some data earlier in the program here, and I'm going to convert that for the non-savvy hex people. It's 49,310, and we remember earlier we stored in values in the 49,310 in the basic program. because these are essentially working together. They're communicating with each other. So it's saying what we did is we're looking at key values that are stored in that location. Now earlier I took all the keys that we had entered in that you saw on the screen, and I entered them in memory locations 49, 310 up to 33 different keys, which is what this is doing down here. This is actually checking for 33 different keys, and it's going to first compare them one by one. So what it wants to do first is we're only going to look at the Y value. So if you had to look at it like this, it would say 828, comma peak. I'm just going to say peak 828 and see what's in that memory location. Let's say, for example, there's a 45 in here. We can see 45 on here. Then we know that it's found at 45. And now it's going to be able to compare it to that memory location and say, okay, now that we found it in 828, we're looking at the note list. Let me check it against the keyboard and see if it exists so we can play it. So that's what this next routine is. This is storing the key values and it's comparing these two back to back to see what is in that memory location. And that's what the increment Y is doing. It's just going to increment through the first 6. You see there's 6 here. Actually, it goes from 0, because it starts at 0, to 6. So 0, 1, 2, 3, 4, 5, 6. Give me the first 6. Let's look at them. Now, I had to do this originally because originally I reversed this X and this Y register and I could not get it to work. So I realized I finally had to first look at each individual note section by section before I could get the other part to work. So give me those 6 notes, compare them against those memory locations, and we're going through that gigantic list you saw in the data statements down here earlier. Kind of put it back on the screen here for you. So we're going through this gigantic list right here. We're going through all of these different key values. You can ignore the rest of these are just the notes. These are not essential to this. So these are looking at all the different notes, which are also stored down here at the bottom. It's saying which notes are we looking at, and let's compare it. We found it in memory location 828 because now we know we want to play whether it's the D, the G, the B, or whatever. And we only need 6 notes for this example. When to make it simple, just play the first 6 notes of Tom Dooley, the song that exists in the book. And then if we found it, then it's going to basically skip out of this next routine, and it's going down to here. It's going to store some values. This is memory location 251. To convert it for you again here. 251. So what we're doing now is we're saying we want to store in the value that we found into memory location 251 so that we know that the routine here, and I'll go back to the basic program here, is able to call and capture that information. Actually, let me just list it right here. Right here you see this S system in machine language. This means get to the start of this machine language or the assembly language program, and say if the keyboard value that we're entering is in memory location 251, hence what we stored right here, bingo, we found a key. Let's go to that routine and let's display it on the screen and let's play the note. So essentially how that's working is it's playing it based on whatever it's finding and searching real quickly through the memory. Now these machine language or assembly language itself is super, super fast. So this is why it's really great to use for basic. You can speed up sprites and just do a lot of great things with it. I love it. I mean, I totally utilized it for Quest for the Mad Bomber and just love it so much. But anyways, we'll get that value here. And then the next thing here it's doing, you see the TXA. TXA stands for Transfer X to the accumulator. What it's doing is it's saying, and we didn't go over this yet, but it's taking the value here in X. You notice there's a Y here, there's an X. It's comparing the first 6 values in memory location, 828 against memory location 49, 310 or whatever it was there. And then it's going to next look at the X value. The X reason why the X exists is it has to look at, after it scans the first 6, it doesn't want to keep stopping there because there's going to be more keys that might exist. So it needs to kind of loop over and over again to make sure it's finding all the essential notes. You could go through the entire list the first time, for example, and you might not even see that first key. It might not even find 37 or something like that. So it needs to go back and loop over and over again so it's able to cover everything. Now, when I originally did this in a basic program, it was super slow because I had to keep rescanning things over and over again, and it's just really horrendous. So the machine language routine is obviously awesome for that. So we're transferring the X value into the accumulator, so we're going to store it in memory location 252. Now, you saw down here earlier, and I'll go back to this again. We're going to hit 1 hour on this. Sorry about that. we're going to store in, you saw these values here earlier, I was capturing for 252 and 253. Now it knows we found a value in 252 to read the keyboard and go to this routine. The next thing it's doing is it's transferring X to the accumulator. So X means whatever the X register is, I want to know where in X did it find that value. And X is incrementing here up to, this is 33. I'm sorry, yeah, 21 is 33. So to convert it here for you guys again, you can see 33. 33, because there's 33 different keys that are just showing up on that first screen you saw when the music player and the jukebox were showing. So now, we're basically saying where in memory is that located. We need to know exactly where it is in the list so we can clear out the proper keystroke. Otherwise, it wouldn't work for me. I just couldn't make it clear out the right keys. It would clear out the wrong notes and play funky notes and repeat notes and do all kinds of crazy, silly stuff. Right here, this whole section here, this is for the musical jukebox. This allows the jukebox to play notes over and over again. And wow, we're almost hitting 1 hour here. Sorry about that. The next one here is this is where you saw this list right routine. Let's say, for example, we already went through, and I'm going to demonstrate that by running since I mentioned that here. And just rerun this real quick. Sorry, this video is going to go over a little bit. We're going to select the list and just play a note here. And we're going to just like pick a different note for the auto jukebox and play it. Let it play a few notes. I'm going to stop right there so I can show you what's going on with this routine right here. So we're going to go back into that list and look at it again. Remember, because the 820 is keeping track of which note is being played and which keystroke is corresponding to that value there. Oh, I actually did this wrong. I should use X. Sometimes I just forget to put in the wrong value there. So 828, I'm sorry, I read too many. So I meant to do 828 plus X. It only give me the values for that memory location. Now, remember earlier we saw 37, 37, 37, 45. Notice now they're gone. Because now the computer understood that we found that value based on where it found X, or in this case where it found the Y stored at, because it was looking at that first keynote stored in 828. We know where they're at, so let's clear them with a 0 so we don't play them again. That's exactly what happened in this list right here. So the reason why I'm showing you that is this routine right here restores them. So once we played the notes and we're done with them, once these all become zeros essentially, let's now go ahead and repeat it so we can get it kind of just to repeat itself to play the music player over and over again. And I'll system call to this to show you. It's system 49192, I believe it is. Right there. Now if I go back and I look at the list here again, you'll see what's happened after I did that sys call. It just restored all those values back into that memory location. Earlier there were zeros in here. Now it says once we played all the notes, let's restore them back so we can essentially just start playing them again in order. That's all that's really doing. This is actually the keyboard routine that you saw me playing the keyboard. And it's very similar to the first one. We're going to erase those 251, 252, 253 so we can utilize and save them. So it's kind of a repeat of the earlier program. With the exception, however, on this one, instead of comparing the original one compared against the 828, the values that we're storing, this one is going to compare them against a list of key codes. And down here at the bottom, these are all the individual keys that you saw on the screen. So if I had to run it real quick here for the visuals. I'm just going to select the musical keyboard so we can leave it on the screen here. You can see the key values here. So it's basically saying all these keys right here are related to these right here because these are the peak 203 you saw earlier. It's picking up when you press that 203, it produces a value, and behind that value tells you which key you're pressing. So it's basically keeping track of which key did we press so we know which key to press on the keyboard to play it as a musical keyboard. And essentially what that's doing is it's reading through a list in X, and this time instead of using Y, you can use X or Y, reversible, it doesn't matter. You can transpose them, whether you want to use X first or Y first. I just get in the habit of just doing them differently sometimes for a different variation. And now we're going to say get the key codes, and we're going to increment through our Y value, not our X value first, because first we're going to be looking at, because we're looking at just for the Y value to get the first 6 from the list. We're not looking at the 828, we're looking at the keyboard. So now we're going to say, look at the keyboard that we found and compare it against a list of key codes so we know which key to play. That's why I didn't use the Y in this section, so I could probably throw this, like I said, this Y loop out and just use the X here only because we only really need the 21 in that. But I have to rewrite the code, so I'm not going to bother with it right now. So it's just basically saying we found a key code according to our list here. We're matching it against the keyboard value so we can play the musical notes on the keyboard. And the same thing, we're capturing the values for X and Y to kind of repeat the same stuff so we know where to position them and when to play them and all that. So I didn't want to make this video so long. It went over a little bit of an hour, but this one was a very in-depth explanation. I know it's a lot to kind of, absorb at once. And I'm sorry if it's kind of confusing. I just wanted to show you. I really enjoy sharing my knowledge. And if, like I said, there's any way I could better teach this stuff to you, I would love to be able to stick it inside your head and get you thinking, like a semi-language programmer. And the reason why I'm probably so addicted to a semi-language, just for a personal story here, is back in the days, in my days, semi-language programming was very in demand. It was very popular. And like I said, I've been reading that book called Hackers. I left it over there somewhere. And it talks about a programmer named John Williams. He was a famous programmer. He invented a Pac-Man clone similar to the original Pac-Man. And Atari tried to sue, at that time, Sierra, or Online Systems they were called, for the copyrights of that program. So what John did is, because he originally copied it, looked like just almost like a Pac-Man clone, he changed the characters, animation, and made it look like a different kind of game, because they didn't own the rights to the actual game or code. They only owned the rights to the character. So he was kind of smart in that aspect. So just kind of there. So semi-language itself was very in demand. I originally took it up in college back in the days. I didn't really go through far enough. I wish I had, because I would learn so much more. But I dropped out, personal life story to the side there, and moved to Arizona after that. But anyways, hope you guys enjoyed this video. I really enjoy putting more videos out there. Kind of another note here, we'll get that machine language project going. It's right around the corner here. And the other thing I was going to mention is I ordered this special device that plugs into my Commodore 64 here, or my disk drive here. It's one of those SD cards, and it should be allowing me to start saving my programs, for example, on my disks and stuff like that, so I can hopefully get them to the desktop. The thing is, I ordered it almost like a month ago. I just got an email from the person, the seller on eBay, told me it's not going to be available to January. So I have to wait till after Christmas for this device to come. I'm not really happy about that, because it was supposed to be here within 20 days, and it's really overdue. But anyways, it is what it is, and what can you do? You just have to kind of wait for it. But it'll really be really great when I get it. I'll just do a demo video on that, and love to show you how that thing works. There are a couple out there for this device, but you'll see what I'm talking about. You can plug it in. It's an SD card. You can store information in D64 files, and I'm pretty sure you can get them onto your desktop computer, from what I understood. So, yeah, I hope you guys enjoyed this video. If you have any questions about this, the program, any things about the machine language, I'm sure, or the semi language, I'm sure I'm going to get questions on that. I'd like to be able to answer your questions. You're welcome to join the machine language project. I don't care if you're a grounds person, you're just starting out, you want to learn, you're curious or whatever. I don't really have any issue with people joining as long as you're cooperative and respectful to everybody else in the group. So thanks for watching, guys. I really appreciate this so much. And if you could really help me in any way, I would love to be able to do this full time. I mean, get the word out about this channel. Let people know that I'm very obsessed with Commodore 64. You can see around me here. And I would love to be able to share this with the world. I talk to people at work, and I'm trying to get in their heads. They call me the Commodore 64 Brain, because that's the name of my channel. I walk in and he goes, "Hey, Commodore 64 Brain." They kind of know me by that name now. Kind of cool. And I wear my shirt one day, and boy, that was interesting. But anyways, if you can get that out for me, I really appreciate it. It's really hard to get a subscriber base going when you're trying to teach programs for a 20-year-old computer. I've noticed this. I've looked at a lot of videos on the Commodore 64, Apple computer, whatnot, and most of them, if any of them, have very low views, because the world out there has moved on. They've gone on to mobile devices, just bigger computers. But let's not forget the roots. We all started with the original personal computers. Now, they had the big mainframes back in the days, and eventually they got them down to the personal computers. But the personal computers were what revolutionized the entire industry. Guaranteed. Without the personal computer, we would not be having YouTube. We would not have these companies that exist today. So this is a very true fact of life. We have so much to be thankful for Apple, Microsoft, and just all those little computer companies that came along the way. So thank you. I didn't want to make this video much longer, but I hope you guys enjoyed it. As always, thumbs up. I really appreciate the likes and subscribes. Sharing the video with your friends. Tell people about me. I really would love. Hit that subscribe button, please. I appreciate that so much. You guys rock and keep going forward. Thanks for watching.